Chapter 10, Advanced IV Calculations. Advanced IV calculations are based on patient weight and have a few more conversion factors. Let's practice with the following example. You have 500 milliliters of D5W with 500 milligrams of lidocaine. This would be called our supply, how the pharmacy has supplied this medication to us. The physician's order is for 0.04 milligrams per kilogram per minute. This is what we would call a three-part order, milligrams per kilogram per minute. The patient weighs 156 pounds and we are using macro drip tubing. The question is, what is the rate to infuse via gravity? Step 1, start with what you know, the weight. Step 2, determine where it is you want to go. Because we are infusing by gravity, we know that our answer is going to be expressed as drops per minute. Step 3, determine the path. The patient's weight was given to us in a pound value, but the medication was ordered by kilogram. So in this equation, we will start with, as we always start with a weight, when a weight is part of the problem, we have our weight conversion factor. The next thing we're going to put in our equation is our order, which is 0.04 milligrams per kilogram per minute. Then we will add our supply, and this is supplied to us from the pharmacy, 500 milligrams in 500 milliliters. And because it's a gravity infusion and we're looking for a drop per minute answer, we will need to have the tubing drop factor in this equation as well. We were told that the tubing drop factor was macro drop tubing, which we understand to mean 10 drops per milliliter. Step 4, calculate. You can see we were able to cross off our kilograms and our pounds and our milligrams and our milliliters by using the conversion factors that we used, which left us with drops per minute, which is exactly what we were attempting to find out. And as we calculate, we find out that the drops per minute factor for this question is 28 drops per minute. Practice 2. The IV with nitroglycerin is infusing at a rate of 6 milliliters per hour. The concentration of the IV solution is 50 milligrams of the nitroglycerin in 250 milliliters of D5W. The question: how many milligrams per hour is the patient receiving at this rate of infusion? Step 1, start with what you know, which is the order, and we know that the current order is 6 milliliters per hour. Step 2, determine where you want to go. What we are ultimately looking for is at this infusion rate of 6 milliliters per hour, how many milligrams per hour of this medication, of the nitroglycerin, is the patient receiving? Step 3, determine the path. For this problem, after we put in our order 6 milliliters per hour, we know that we would have to put in the supply, how the pharmacy supplied this medication to us, in order to determine a milligram per hour rate. Step 4, calculate. At a rate of 6 milliliters per hour and using this supply factor we we find out that the patient is receiving 1.2 milligrams per hour of medication. An intravenous medication that needs to be given but is not the primary solution is done by piggybacking, abbreviation IVPB, the medication into the primary line. Before ever piggybacking a medication into a primary line, be sure to check the compatibility of the two solutions in your drug book or a compatibility book. The calculations are done in the same way as any IV calculation, and you are generally seeking a milliliter per hour answer, as most medicated IVs are infused using an infusion pump. In this photo example, the larger bag is an example of a main IV line, and the smaller bag contains medication that you will be piggybacking into the main line. The nurse will then infuse this medication using an infusion pump. Practice 3. A patient with an infection is to receive an IV piggyback of ampicillin 500 milligrams in 50 milliliters. Pharmacy directions state this IV piggyback should be infused over a 30-minute time period. So the question is, what flow rate will you set on the infusion pump in order to comply with this order? Step 1, start with what you know, which is the order. Our order is to infuse this 50 milliliters of solution over a 30-minute period of time. Step 2, determine where you want to go. We are going to use an infusion pump, so what we ultimately need to know is what is going to be our milliliter per hour infusion rate in order to comply with the pharmacy directions. Step 3, determine the path. Since we are seeking a milliliter per hour answer, we need to convert our minutes into hours. Step 4, calculate. Our calculations show that in order to comply with the pharmacy directions to infuse this 50 milliliters over a 30-minute period of time, we will need to infuse at the rate of 100 milliliters per hour. Medications can also be administered by injecting or pushing them directly into an existing intravenous line. This is called an IV push. The abbreviation for that is IVP. These are usually relatively small volumes of medication, and the rate per minute at which these medications are pushed intravenously can be referenced in a drug book. As with piggyback medications, it is necessary to check the compatibility of an IV push medication with the mainline solution. Let's practice. You are ordered to give 80 milligrams of Lasix IV push stat, which means immediately, for a patient in congestive heart failure. According to the drug guide, the medication should be pushed no faster than 10 milligrams per minute to avoid seizures. Question: if the label on your supply is 10 milligrams per milliliter, how long will it take the nurse to administer the medication IV push? Step 1. Start with what you know, the order. We are going to give this patient 80 milligrams of Lasix. Step 2. Determine where it is you want to go. Ultimately, I want to know how many minutes it should take me to push this 80 milligrams for this patient. Step 3. Determine the path. The drug manual advises us to not give this medication any faster than 10 milligrams per minute. Step 4, calculate. By eliminating labels we do not need anymore, the milligrams, we know now via calculation that we need to administer this 80 milligrams over an 8-minute period of time in order to ensure patient safety. Blood is administered intravenously using special tubing. An example is pictured below. Practice 5. You have 350 milliliters of packed red blood cells that you want to infuse IV over 2 hours. There is an IV pump to use, and your blood tubing delivers 10 drops per milliliter, also referred to as macro drop tubing. The question is, what flow rate will you set on your infusion pump? Step 1, start with what you know, the order. You want to infuse 350 milliliters over a 2-hour period of time. Step 2, determine where it is you want to go. Because we are using an infusion pump, we know our answer will be expressed as milliliters per hour. Step 3, determine the path. Since we are already at our pathway, milliliters per hour, we are ready to calculate, and we don't need any further conversion factors for this particular calculation. Step 4, calculate. In order to deliver 350 milliliters over a 2-hour period of time, we will set our infusion pump for a rate of 175 milliliters per hour. Now that we have finished the practice examples, complete the review questions at the end of Chapter 10 and check your answers in the back of the book. Complete your homework exercises for Chapter 10 and submit for grading. If you have any questions for your instructor or need further clarifications, do not hesitate to contact your instructor.